Voyager 1 was drifting silently through space, its thrusters dead, its future uncertain. But just when all hope seemed lost, NASA pulled off a miracle. The spacecraft is alive again, and what it might do next could shock us all. In 1977, NASA launched two ambitious robotic explorers, Voyager 1 and Voyager 2, to fly by the gas giants of our solar system. These spacecraft were never expected to remain operational for more than a few years, yet they defied expectations in ways no one could have predicted. Decades later, these two spacecraft are still operational, boldly pushing through interstellar space, well beyond the influence of the sun. They are now pushing farther than any machine humanity has ever built, silently carrying our dreams into the cosmic unknown. Voyager 1, currently over 15 billion miles, 25 billion kilometers away, has become the farthest human-made object from Earth, a silent ambassador of Earth drifting through the unknown. It continues to drift in a realm where sunlight is a memory, and the gravitational hold of our sun is barely a whisper. But even heroes face challenges. After nearly 5 decades of operation, a critical problem emerged. A set of thrusters essential to orienting the spacecraft had been considered dead since 2004. The fact that a spacecraft launched with 1970s technology is still operational is nothing short of extraordinary. Its computer systems are ancient by today's standards, less powerful than a basic digital calculator. Yet it endures. This resilience is a tribute to the foresight of the engineers who designed it, and the tenacity of the teams who continue to support it. But now, NASA's Jet Propulsion Laboratory, JPL, has revived the long-dead thrusters just in time, ensuring the mission's survival before a scheduled communication blackout. In this video, we will discuss the story of how Voyager 1 cheated death yet again. Voyager 1's ability to communicate with Earth depends on precisely pointing its high-gain antenna at our planet. To maintain this alignment, the spacecraft uses small thrusters that adjust its orientation in space. These include thrusters that control pitch, yaw, and roll. Roll control is particularly vital. It rotates the spacecraft like a vinyl record to keep it locked onto a guide star. There are primary and backup sets of thrusters for this function. However, in 2004, the primary roll thrusters stopped functioning. Two small internal heaters failed, leaving the thrusters too cold to operate. NASA engineers at the time decided to rely solely on the backup roll thrusters, which remained in working order. At that time, the team was okay with accepting that the primary roll thrusters didn't work because they had a perfectly good backup, said Kareem Badoudin, Voyager mission manager at JPL. And frankly, they probably didn't think the Voyagers were going to keep going for another 20 years. But fast forward to 2025. After decades of use, the backup roll thrusters began to clog due to residue buildup in the fuel tubes. Without roll control, Voyager 1's antenna would drift off target, and communication with Earth would be lost. That would mark the end of the mission. This problem was compounded by a looming communications pause from May 4, 2025, to February 2026. The only Earth-based antenna capable of sending commands to Voyager, the Deep Space Station 43, DSS-43, in Canberra, Australia, was scheduled for months of upgrades. Unlike other parts of NASA's deep space network, DSS-43 is uniquely equipped with the power needed to reach Voyager. Its temporary unavailability left NASA with an urgent deadline. If the backup thrusters failed during that period, Voyager would go silent and no command could reach it in time. The engineering team had no choice but to attempt something previously deemed impossible: reactivating the dead primary thrusters. The decision to attempt reactivating the long-dormant thrusters wasn't made lightly. NASA engineers suspected that the original 2004 failure wasn't due to irreparable damage, but perhaps a circuit disturbance that flipped a power switch off in the heaters that keep the thrusters warm. If this theory was right, they could attempt to send a command to reset the circuit, effectively turning the heaters back on. But the operation was risky. If the heaters failed to turn on and the thrusters fired while still frozen, it could trigger a small explosion, damaging the spacecraft. Moreover, if Voyager's star tracker drifted too far from its guide star during the process, the onboard software could autonomously fire the dormant thrusters while still cold, leading to the same catastrophic result. The team had to act fast. They meticulously planned the sequence, aligning the star tracker with precision, warming the thrusters gradually, and timing the commands perfectly. On March 20th, 2025, they anxiously watched their screens as Voyager executed the sequence. Due to the spacecraft's extreme distance, it takes over 23 hours for a signal to travel from Earth to Voyager, and another 23 hours to return. When the team saw the confirmation signal, they were actually witnessing something that had already happened nearly a day before. But what they saw stunned them. The temperature of the thruster heaters had risen dramatically. The heaters had turned back on. The thrusters once considered dead had come back to life. "It was such a glorious moment," said Todd Barber, the mission's propulsion lead at JPL. "These thrusters were considered dead, and that was a legitimate conclusion. It was just that one of our engineers had this insight that maybe there was this other possible cause, and it was fixable. It was yet another miracle save for Voyager." The reactivation of the primary roll thrusters offers Voyager 1 a new lease on life. It provides engineers with an essential backup in case the current thrusters clog completely. More importantly, it ensures continued orientation control, which is crucial for maintaining communication with Earth as Voyager travels through the interstellar medium. The revived thrusters are not the only recent highlight in the Voyager mission. In April 2024, after a 5-month data outage due to a corrupted memory segment, Voyager 1 successfully resumed sending usable engineering data. By May 2024, all 4 science instruments were back online, returning critical information from the edge of the heliosphere, the bubble around our solar system created by the solar wind. In February 2025, NASA took another strategic step by shutting down the cosmic ray subsystem to conserve energy, preserving power for other key instruments. The low-energy charged particle instrument is expected to remain online through the end of 2025. These moves are part of a calculated effort to extend the mission well into the 2030s, even as onboard power levels continue to decline. What Voyager 1 continues to observe is of immense scientific value. It's measuring the density, temperature, and magnetic field strength of interstellar plasma, data that no other spacecraft can currently provide. Its findings shape our understanding of the Sun's influence on the surrounding space environment and help define the true boundary between our solar system and the rest of the galaxy. Moreover, this mission acts as a test bed for future interstellar probes. Its endurance informs designs for spacecraft intended to leave the solar system permanently. NASA's ongoing Deep Space Network upgrades, partly motivated by lessons from the Voyager program, will benefit new generations of missions, including Artemis lunar landings and future missions to the outer solar system. Voyager 1's story is a testament to human resilience, daring, and imagination. It tells us that even when the odds are against us, when the tools seem broken, and when time is running out, a solution may still be possible. If we believe, if we look harder, if we think differently. This spacecraft is more than metal and circuits. It's a voice from Earth, whispering through the void, telling the universe that we were here, and that we cared to understand. Even as Voyager 1 sails farther into the vast interstellar void, its journey is not only a technical marvel, but a profound philosophical reflection on humanity's place in the cosmos. It carries the iconic golden record, a 12-inch gold-plated copper disc encoded with sounds, music, greetings in 55 languages, and images portraying the diversity of life and culture on Earth. Meant for any intelligent life that might someday discover the spacecraft, it stands as a time capsule of who we were and what we aspired to be. The existence of this message speaks to our species' optimism, that even in the cold emptiness between stars, we dared to dream of being found and understood. Voyager's continued survival is not just a victory of machines, it's a victory of imagination. Its faint, whispering signal reminds us that even as we fight our daily battles here on Earth, a piece of us is out there, calmly, silently, persistently reporting back from beyond the known. As power dwindles and systems slowly shut down, each new transmission becomes more precious, a heartbeat from the edge of forever. Eventually, Voyager will go dark, but even then, it will continue drifting for billions of years, long after we are gone, still carrying our story among the stars. Thank you for watching. Don't forget to like, subscribe, and hit the notification bell so you never miss an update from the edge of the solar system and beyond. Until next time, keep looking up.